Hello class, today we're going to learn the first of two trig laws. Now these laws are now applied to triangles that do not have to be right angled. The trig ratios had to be right angled, whereas these laws do not have to be. So the first law we're going to learn about is called sine law. Before we start to dive into sine law, we're going to first have to remember how we write triangles and label them. So when we label triangles, we label angles using capital letters. So for example, this could be angle A, angle B, and angle C. They're always written in capital letters written at the vertices. Side lengths are written in lowercase letters. And what they are written is always across from where the angle is. So if this is angle A, the side length A would be across from it, and it'd be written in lowercase, like so. And then the angle B here will have a side length across from it written as a lowercase b, and then angle C, the side length would be C across from it as well. Okay, so don't forget this convention because it'll be important for when you write these trig laws. So what is sine law? So sine law can be written in two formats. One where we're discussing the side length and one where we're discussing the angles. They are the exact same formulas, but they're going to be, one's more convenient for one type over the other. So here is the sine law written for side length, where it's the ratio of one side length A over the sine, remember that trig ratio sine, of the angle A. So it's this ratio is equal to the ratio of the side length B over the sine of the angle B, and that is also equal to the ratio of side length C over the sine of the angle C. So as you can see the pairing here. Now when you use the sine law, you only have to use one pairing. So as long as you have two pairs, so like one pair of one side length and the angle and another side length and another angle, you only have to use two of them. So you can use A and B, you can use B and C, or you can use A and C. It doesn't matter which pair you have as long as you have two pairs that you're interested in. Now the angle version is actually the flipped version of the side length. Where you see here now the sides are in the denominator and the angles are on the top. So they're the exact same formula, just flipped. The reason why we just show this one is just that it's easier if you're solving for the angle to have the angle on the top is all. Okay, so whichever version you need, use that version and then write out as such. Again, you only need two pairs to solve. So sine law, when do we use it? So when we are given a triangle and we have two angles, for example, if we have A and B and we have one side length such as little b, then we can solve for the missing side length A. Okay. Another way we can do this is if you have two sides such as C and B and you have the one angle, for example, capital B, and you need to solve for the other angle C. Okay, so let me show you a couple examples for you to understand how to use sine law. So the first one we're going to use is this triangle here, where we have, as you can see, the angles A, B, C, and the side lengths would be little a over here, little b over here, and little c over here. Okay, so given what we have, we would see that we have one angle missing here. So we need a pair. Remember how we said that with sine law, we need to have a pair. So either we have to have a pair of the angle and the side length value, which we don't, or if we look at the other angle here and this side length, nope, we don't have that either. But this one here, we have a side length, but we don't have an angle. Well, we might have to use some other information that we know about triangles first. And that first thing we know about triangles is that the angles inside of any triangle, right or non-right angle, is that they always add up to 180. So if I have these two angles here, I can figure out what angle C is. So angle C is going to be 180 minus 75 minus 42 degrees. This gives me an angle C that is 63 degrees. So now that I have that information, I have a pair. So in sine law, you always need a pair of an angle and a side length first. So that means that I can use part of the equation, and I'm going to use the equation that has, because I'm solving for a side length, therefore I'm going to use the side length version of sine law, so this one here. And because I have the pairing of C, I'm going to make sure that part is my equation, as well as the one pair that I'm looking for. So because they didn't tell me which side length to use, I'm just going to go with A. So I'm going to use this pair with this pair in my formula. So this is going to be the formula I'm going to write. I don't have to include the B over sine B because that's not what I'm using at the moment. I only need to have like two pairs here, one pair here and one pair here. So I'm going to fill in what I have. So I have on the right side, I have the angle, the side of 22, and then sine of the angle, which is 63 degrees. On the left side, I still have, I'm looking for the side length A, but I do have the angle A, which is 42 degrees. So now it's just a matter of solving this equation, which means I have to isolate for the variable little a. And so to isolate it, I have to multiply both sides by sine of 42. Like so. That will eliminate 42 on the denominator here, so I can cancel those out. So my formula, or my equation that I'm using is therefore 22 over sine 63 times sine of 42. So you can type in your calculator 22 times sine of 42 divided by sine of 63, or do this first and then multiply by 42. It doesn't matter. And that gives you that the side length of A is approximately 16.52 centimeters long. Okay, and I could do the same thing using A now, or the pairing of C to solve for the side length B. Okay, but we're going to move on to the next one, which is how to solve for the missing angle. So here in this pairing, we have a pair of an angle here, angle V, with its side length little v over here, 5.6. And I have the side length 7.3 meters, which belongs to little u. And I'm maybe looking for the angle, capital U. Okay, so therefore I'm going to use the sine law version where the angles are on the top. So as you can see here, I just relabeled the sine law with u's and v's, but I put capital U, sine of capital U on top, and little u on the bottom equals sine capital V on top over little v on the bottom. Okay, so you can relabel the sine law using the appropriate letters as you need, just keeping that the sine is with the capital letters and the side length is on by itself. Okay, so I'm going to use this formula and fill in what I have. So I have sine V, so sine of 32 degrees on the top, and the little v would be 5.6. And on the left side, I have sine capital U, which I don't have yet, so I'm just going to keep it there. And the little u is the side length, which is 7.3. Always making sure that the side length and the angles are appropriately paired in the equation. And so I'm now trying to solve for my unknown, which is my capital U. That means I have to isolate for u. And so when I do that, I have to get rid of all the numbers and such around it. First, I'm going to get rid of this 7.3 that is currently being divided. So I'm going to multiply it on both sides as such. And because it's multiplying by a constant, I'm going to bring it to the front so I don't get confused with sine of 32 is separate from the 7.3. So right now my equation looks like this. And now I need to isolate for u. And remember that when I'm isolating for u, and it's currently embedded in the function of sine, to get rid of it, I have to use the inverse of sine. And so I will write sine inverse to get rid of it on this side. So I do to one side, I'll have to do to the other side. And remember that when I'm applying it, I'm applying it to the whole right side. So that's why it has to be in brackets and sine inverse in front. So my equation will now look like a capital U is equal to sine inverse and brackets this large fraction of 7.3 times sine of 32 divided by 5.6. So make sure you type this in, what's in the brackets first in your calculator, 7.3 times sine 32 divided by 5.6, and before you apply the inverse of it. If you're trying to follow along in your calculator, 7.3 times sine 32 divided by 56 should give you 0.6907 and so forth. And then when you take the sine inverse of that, make sure you keep that all in your calculator to be as accurate as possible. And then you should have that the angle of u is now equal to 43.69 approximately. So I'm going to round that to that the angle of u is equal to approximately 44 degrees. Okay? And so that's how you would solve for the missing angle. So just to recap, Sine Law has two pseudo versions, like really is just one version of the formula where the side lengths are on the top and the angles are on the bottom, or the angles are on top and the side lengths are on the bottom. Just making sure that you have a pair of side length and angle in order to calculate another either side length or the angle. Okay, so try it out and good luck.